Hello, this is Paul from Foresight Tech. In this lecture, we are going to deal with the parametric curve, which we defined in the last topic, right, using calculus. And the first, we're going to see what the tangent for the parametric curve. And to define the tangent in our equation, we need to find the slope, right? How to find the slope, which is the first derivative. And later, I will give it the second derivative. So here, suppose we have a parametric curve here, and the parameter is t. And how to find the slope? The slope, which means dy dx, right? We do not have a relationship directly, a direct relationship between y and x, but we do have a middle t to link both together. So we have a chain rule, right? Okay, everyone. So can we do this? We times the bottom both sides. So we can look at dy dt equals dy dx times dx dt, which is the chain rule. Okay, so this formula gives us the relationship. Okay, we use chain rule, easy to find. How about the second derivative? The second derivative, when we're talking about the concavity, okay, so we need the second derivative, right? Second derivative is the first derivative take derivative 2x, right? Can you see? The first derivative take derivative 2x. Or we simply see this one, okay? If we cancel dt, dy dx again, that's the definition of second derivative. The same understanding from the first. What is dy dx? Dy dt dx dt, if we cancel dt, that's exactly dy dx, right? Okay, so this is the formula. I'll give one example how to use the formula. Here. So we find this, find the tangent in our equation to the cycloid. Remember the last topic we discussed was the cycloid, or at least in trigonometry we learned the cycloid, okay, a long time ago. Okay, this is a parametric equation at the point where theta equals pi over 3. Give you theta means what? We know a point x and y, right? We know the point on the curve, and we need to know the tangent in our equation. All we need is the slope. Okay, so if I put here or something, can you see? We need to find the slope, right? We use the point. We use the point slope equation. I'll put the equation here first, which is y minus y0 equals m, the slope, right, times x minus x0. All we need to do is find the point, and find the slope. Okay, so these two, and then plug into the point slope equation, and then we have the equation. Let's go into the point first. Okay, so I put a point here. What is the point? We need to find the x0, which means the x at theta equals this point. Okay, so we're going to find the x0 is r times, can you look at this, plug in theta equals pi over 3, which means pi over 3 minus sine at pi over 3, right? Okay, so this is one. And this power 3, this is sine at 60 degrees square root of 3 over 2, right? So I plug in. The first is pi over 3. The second is square root of 3 over 2. Okay, we cannot simplify. I'll just leave it here. What is y0? We put this together is the point. Y0 is y at theta equals pi over 3. So it's r. And 1 minus cosine at pi over 3. And what is? And the cosine at 60 degree is sine at 30, 1 out of 2. 1 minus 1 out of 2 is 1 out of 2, right? So 1 half. So which means r over 2. Okay, so this is one. The second, we're going to find the slope. So what is slope? And they're going to find the slope. We need this. We need the derivative, right? So I will say dy dx. The derivative functions first. What is dy dx? Okay, dx is linked by this time the parametric the parameter is theta. Okay, so be careful, we need to do what? dy d theta, right? Remember this, y can d theta, and the bottom is dx d theta. Okay, this is the formula we just discussed, and then plug in. What is dy d theta? Okay, dy d theta here. Okay, if we take a derivative to the first term, 0. Take a derivative to the second is sine, which means r times sine theta. dx d theta, dx d theta, we have 2, right? The first is 1, the second is cosine, which means r times 1 minus cosine theta. Okay, you know we can simplify a little, right? We cancel the r. So what we get is sine theta 1 over 1 minus cosine theta. Okay, so this is dy dx, the general function or derivative, but we do need the derivative at this point, which means what? So we do need the m. What is m? You know m is dy dx at theta equals pi over 3. Okay, all we need is this, plug in. The plug in, see, I will do the calculation here. Sine at 60 degree, sine at pi over 3, we do know the value. 1 minus cosine at pi over 3, we do know, right? And the plug in here. What's the one? The first is the square root of 3 over 2. 1 minus 1/2, right? 1 minus 1/2. You times 2 both sides, definitely will get a, here's 1, here's square root of 3, which is the square root of 3. Okay, now almost, right? What do we have? We do have m, we do have the point, and then the tangent line equation. Now we finally find the tangent line equation is this. Okay, by the point the slope y minus y0, where's y0 here? R over 2, right, equals m. M is there. Okay, square root of 3, parentheses, x minus x0, which is there. Okay, it's non-k. So I put this. R times parentheses pi over 3 minus square root of 3 over 2. We cannot get a very simplified equation. Okay, so I just leave it here. Probably you can plus this to the right and distribute it, find another form, but it's still the same. Okay, so I just leave it here, and this is all. Thank you.